The AI blueprint, how artificial intelligence actually makes predictions. Under every flashy demo, fraud detection, image generation, chatbots, sits one foundation. Learn patterns from examples, then calculate the most likely outcome on new data. Analyze examples. Extract patterns. Forecast. That is the whole game. Picture the machine. Inputs enter as sensors, images, or text. Inside, a weight matrix, a summation, and an activation function forge a single glowing prediction. Not magic, engineered signal flow from data to decision. The big shift, traditional software is the rule maker. A programmer writes, if delayed over 1 hour, approve refund. Machine learning is the pattern finder. Feed thousands of historical cases. The algorithm discovers its own rules and outputs probabilities, refund likely 92%. Instead of writing the rules, we provide the examples. Anatomy of a decision. Features are the inputs, order value delay, prior refunds, fraud flag. The label is the target, refund approved. Training data is only a sample of a messier real-world population. Warning, a powerful model on a bad sample will confidently fail. 2 phases. Training, the model sees labeled data, predicts, measures mistakes, and adjusts internal weights, learning from millions of faces. Inference, weights freeze, new unseen input in, prediction out, is this new face smiling? Learning versus applying. Weights are importance. Each pixel is 0 or 1. Connections amplify mouth region pixels for smile detection and shrink irrelevant ones toward 0. The score is pixel 1 times weight 1, plus pixel 2 times weight 2, and so on a final prediction score. In code shape, loop features and weights accumulate the score, then pass through a sigmoid to get a probability between 0 and 1. That is the bridge from raw math to a confidence you can act on. The continuous cycle. Predict with current weights, compare to the label, calculate error, expected minus predicted, then adjust weights slightly to reduce that error. Golden rule, you cannot perfect one sample, seek balanced weights across the whole dataset. Raw network outputs like 25 or -4 are unreadable. Sigmoid compresses any score into confidence between 0 and 1. 0.93 means strong yes. 0.5 is total uncertainty. 0.07 is strong number. Ideal for binary calls like fraud or smile. Gradient descent walks the error valley. Check the slope, step downhill toward the optimal minimum. Learning rate too large overshoots. Too small stalls forever. Balanced steps approach low error efficiently. See the landscape. High peaks of error, a blue basin of the optimum and 3 paths, wild orange overshoot, tiny gray crawl, and the balanced blue descent. Optimization is navigation, not luck. Accuracy alone lies. On 99% legitimate transactions, always saying not fraud scores 99% and catches 0 fraud. Use precision, recall false positives and negatives, and calibration. Overfitting memorizes training points. Generalization learns the pattern and survives new data. Raw reality is chaos. Preprocess, detect, rotate upright, crop, normalize brightness, convert to a pixel matrix. Pipeline over monolith, specialized steps feed a final predictor. A smile model trained on upright faces fails on tilted photos without this prep. Deep means stacked layers of representation. Pixels become edges, edges become shapes, shapes become facial features, then a smile prediction. Deeper networks unlock complex patterns and demand more data, compute, memory, and anti-overfitting discipline. Production is an ensemble. User prompt to generation model, through a safety model that can reject harmful content, then ranking, then final output, with continuous drift monitoring overhead. Infrastructure needs APIs, auth, latency, versioning. Models rot as the world changes, retrain. The production schematic, prompt, generate, safety gate, rank, deliver, radar watching for data drift. Real AI systems are orchestras, not soloists. Large language models use the same foundation at monumental scale. Instead of pixels to a binary smile, tokens like the sky is mapped through transformers with attention and billions of weights to a next token distribution. Blue 85%, cloudy 10, dark 4. Same features, weights, errors, and optimization, infinite scale. The infinite loop. Collect data, extract features and labels, train with gradient descent, validate on unseen data, deploy, monitor drift, retrain with real-world data, forever. AI is not magic. It is an engineered system for learning patterns. Quality lives in data integrity and continuous evaluation. That is the AI blueprint, from weighted sums to production ensembles and LLM scale. Subscribe to Life of Geeks, comment blueprint for a from-scratch coding episode, and scan the QR code. Theory today, we build next.